in 5, 4, 3. Welcome to pre-calculus. Live studio audience right here. And this is lesson, what is this again? Oh, 8-5. Yes, lesson 8-5. Okay, home audience, follow along. All right, so for today's buzzword, perhaps some of you did a little something called the Pythagorean theorem. All right, so you do this. 6 squared is 6. 10 squared is 100. Subtract 36 from both sides, and you get b squared equals. Huh, how about that? A perfect square minus the other perfect square gave us a third perfect square, which happens every once in a while, and you get b equals 8. So that is called a 6, 8, 10 what? Pythagorean triple. We'll call it pi triple. All right? So that is a Pythagorean triple because they're all nice integers. Now, over in the other one, let's see what happened when we tried the other one over here. 4 plus 25 equals c squared. Is that going to work out nicely? And that c squared equals 29, isn't it? Oh, well. Can't all be triples, right? So c equals, now technically, when you take the square root of both sides, it's actually plus or minus 8. But the length of a triangle of one of the sides would have to be a positive number, right? So we know that. So you end up getting square root of 29. Okay? All right. So you get 2, 5 square root of 29, which is not a triple, of course. It works in the theorem. It is not a triple because this is an integer, this is an integer, and furthermore, they're whole numbers. But this is a what type of number? Take the square root of 29, it just goes on and on, irrational. Remember those? Just like pi. The decimal goes on and on forever, and there's no pattern. All right? Just totally random. Okay? So that is irrational. So I'm sorry to say, you are not going to be a Pythagorean. All right? Okay. So let's go ahead and check out some other things, such as examples of Pythagorean triples. Now, some of you cheated, look at the bottom. But anyways, hopefully some of you actually remembered some triples off the top of your head. Now, there's one that everybody knows. 3, 4, 5. 3, 4, 5 is the classic. Okay, that's good. I wonder if that has any relation to the 6, 8, 10.
It does.
You know what? It's just double. Yeah. 6, 8, 10.
Triple it.
This is called a multiple. We could, but this one has a different name for it, right? If it is not a multiple of another triple, if it's a triple all by itself, it is called a, it's similar prime, it's from the same word, primitive, comes from the word, so primitive Pythagorean triple, which means the greatest common factor between all three numbers is 1, and there's no other common factor, okay? So that's a primitive, that's a multiple, all right? Let's see, you could have also tripled it. What's that going to be, 9, 12, 15? Sure. All right. There were some others. Has anybody ever been in Algebra 1 or Algebra 2 and seen the 5, 12, 13 by chance?
Yes.
Okay, that pops up from time to time. And actually somebody in second grade named the 7, 24, 25. I was very impressed.
I had written down. I was at the bottom.
All right, well, that's one that you see every once in a while. Now, you can't go too far because in Algebra 1 and Algebra 2, they're not going to give you ones that are like gigantic numbers. So they stay to the small ones, okay? And there aren't too many to choose from here. So, okay. So let's take a look at our history, first of all. It's time for history moment. Except we don't have history moments every day, I guess. But it's a very special segment. And we'll have Mr. Wade's mailbag someday, too. Okay. We have a letter from the studio audience. And a letter from home. Okay. All right, so, mathematical discovery. Pythagorean triples were used in architecture, but they did not know the Pythagorean theorem. They just figured them out by trial and error. Oh, 3, 4, 5 works perfectly. Oh, 2, 5, no, that one doesn't work out. Oh, good. Okay. So the first triples were just discovered by accident, but they knew they worked. And this is about 2000 BC. Let me get that first column there, all right? Okay, now, hint. First of all, this is in the Middle East. The other hint is that they were one of the most sophisticated intellectual people that lived at that time. You had actually two groups in the Middle East that were very intelligent. You had Egyptians, and then you had these guys. Babylonians, nice.
Someone actually paid attention to history.
I'm impressed, yes. All right. So, the Babylonians, very intelligent people. Now, believe it or not, see that little stone tablet there at the top? That is actually a picture of a stone tablet they found that was 4,000 years old. And in their language, they have Pythagorean triples written on that tablet. Isn't that amazing? It's 4,000 years old, and that was the first time people ever wrote down Pythagorean triples. Okay?
That you know
Yes, that they found at least, yes. Okay? Fascinating that it existed that long ago. They didn't know the theorem, but they knew that these worked in the right triangles. All right, now, let's go on to the next trivia. The Pythagorean theorem was finally discovered and written as, what's that? What's that here? Yeah, this is the Pythagorean theorem. What are those letters?
Greek letters.
What's that?
Fish.
Alpha squared, fish. Alpha squared plus beta squared equals
Yeah.
the third letter of the Greek alphabet, which is gamma. Gamma squared, yeah. That was before we Americanized it and made it a squared plus b squared equals c squared. But it used to be this in the beginning, all right? And this was discovered in 550 BC. So this is still a long time ago, all right? 550 BC. And the person who discovered the Pythagorean theorem, who lived in Greece, who it was named after, was Pythagoras, of course. All right, that's Pythagoras. And his picture is at the bottom, or at least his sculpture is at the bottom. And we have hints about who these people are. All right, there's Pythagoras.
That's so good.
All right, now let's see who's next. Okay, Pythagorean theorem proven. Pythagoras didn't even prove his own theorem because he couldn't figure out how to prove it, but he knew it worked. Somebody had to come in later and prove the theorem, all right? And that was about 300 BC. All right? No, that was not me. I was not that old. All right? Now, who proved the Pythagorean theorem? I'll give you a hint. He has an entire field of geometry named after him. Euclid, for whom Euclidean geometry is named, right? Remember, Euclid is one of those dudes that used to roam around the Alexandria library, right? Remember, Euclid, Eratosthenes was there, Aristotle, Socrates, Socrates, all those guys, right? Roaming around the halls there. Okay, here's one of them. He is the number, now look at this, the number 11 mathematician of all time, just outside our top 10. Okay, he's a heavy hitter. He can't write a paper on him, but you can admire him. Okay, so next, a Greek philosopher wrote a formula that generates infinite random Pythagorean triples. This is taking a step back, actually. This is 400 BC.
This is a little off topic.
Okay, yes.
Since we're talking about the 10th.
Sure.
February 1st is a Wednesday.
Yeah, we said in class that you could make it Thursday, and that's fine. I meant to put February 2nd, Thursday, so Thursday, so So yes, the 2nd, which is Thursday, is fine. I meant to put the 2nd on a Thursday, so, okay? Remember that, kids at home? Do Thursday. Okay. All right, now, let's do this. Which Greek philosopher, he was a mathematician on the side, but he is considered the second greatest philosopher ever to Aristotle, who's number 1, and this guy was Plato, second only to Aristotle. Now, his mathematical rank is 110, which is not bad, considering that his philosopher rank is number 2. All right? This is just his side hobby. He was in the top 110. That's pretty good. Not bad. All right? So, pretty impressive. So Plato the philosopher was coming up with this stuff too. These guys are all walking around those halls of that library. Okay.
Wait, what year was that?
That was about 400 BC.
Oh, sorry.
And there's Plato's picture right at the very bottom.
Which one?
And you can see him right there. That's Plato.
The third one?
Okay, that's the third one. So we've got Pythagoras, Euclid, and then Plato, those three right there. All right, now the next guy looks a little bit more modern here from a painting. Formula discovered that generates infinite of the primitive triples, but still not all of them. All right, this one, well, that's the right time period almost. Italy is the hint. This was the year 1202, and I'll give you a hint. He has a very famous sequence named after him.
Fibonacci.
Fibonacci.
Wow.
That's 80.
I'm impressed. Fibonacci is number 20 all time. Anybody ever learn the Fibonacci numbers, by the way?
I did a project on it. It was like 1, 2.
Nice. Yeah, it starts with a 1, 1. 1 plus 1 is
The
2.
Durham project.
1 plus 2 is 3. 2 plus 3 is 3 plus 5. And you just keep adding the two previous numbers to make the next one. So the two previous add together to make the next one. And they found out that it's not just for fun. Fibonacci figured out that these are built into things in real life. Sunflowers. If you kept the little beads in the middle of a sunflower, they match these numbers as they spiral out perfectly. Isn't that amazing? Every one of them. Just fascinating. Seashells, like the little conch shells that come out like this. Yep. They have that ratio all the way through. Even they figured out that some breeds of rabbits multiply at this rate right here. Follow the Fibonacci numbers. How about that? And then it just goes haywire after a while, as you know. Hence the phrase. Anyway, okay. So that's that. So Fibonacci figured out those and this over here. Okay. Now let's go to the next person. He looks familiar down there at the bottom. I wonder who that is. 17. That's not George Washington.
Pete Wade.
That's not me either. I don't wear a powdered wig. Okay. This guy right here, who is not George Washington,
Your dad.
and not Pete Wade, not my father, 1769, okay, a long time ago, he came up with a better formula for infinite Pythagorean triples, and he is the greatest mathematician to ever live.
See the
Numero uno.
Euler.
Leonard Euler. And you cannot write a paper about him because we're going to do a quiz on him later. All right? So, he had a big breakthrough as well. All right. Now, it's deceiving that it says Russia when he was 62 years old because he was actually Swiss. He was just living in Russia at the end of his life. All right? St. Petersburg. All right. Next one was in 1934.
The flag, Sweden.
Okay? Yes, there's no picture of this guy, so we put a flag of Sweden there. But he figured out a formula that gets all the primitive triples, which means if you have all the primitive triples, guess what? You can go multiply in your free time by 2 times 3 times 4 times 5 and get all the triples. Yeah, well, guess what? This guy's cheating.
No.